5.3b, solving rational inequalities. Now, last lesson we solved rational equations, and now we're going to solve rational inequalities, which is a little different. In each case, keep in mind that since we are dealing with rational expression, you have to worry about undefined values in the denominator. Okay, so let's start by solving a rational inequality given a graph, so which we have here. So if we look at this problem, they want to solve three things. Where does the function equal 0? Where does the function less than 0? And where does the function greater than 0? So we're going to solve all three of these. So where does f of x equal 0? Where does f of x greater than 0? And where does f of x less than 0? So by looking at the graph, f of x equals 0, right, where it equals x-intercept, right here, only at one spot. That looks like -1. So there we go. Where's f of x greater than 0? Well, look at our graph. Here's 0. You're greater than 0 right here. So this would be -infinity all the way to -1. And then again, it starts right here. So there's a vertical asymptote we can't see, but there's a vertical asymptote right here. And it starts right here at 0 all the way on forever. So this will be from 0 to infinity. So -infinity to -1, union 0 to infinity. It's where our graph is greater than 0. That's where we're above the x-axis. So from here, right here, and right here. And then finally, where's the graph less than 0? So where are you below the x-axis? And that looks like it's just right here. Right? That little portion right there. And that portion starts at -1 and goes all the way to our vertical axis right here. Vertical asymptote right here. So only from here to here. That little spot is where you're less than 1. You're less than the x-axis. So from -1 to 0. Right, so everything above here, you're above it, and this is the only little spot where you're below the x-axis. If you notice, I put parentheses because you cannot be the values here and here. So there's that one. Let's answer the same question with the next one. Okay, right here. Where does it equal 0? It only equals 0 at one spot, and that's right there at 0. So it equals 0 at 0. Then I want to know where is it greater than 0? Well, it's greater than 0 here and here. Right, so look right here. It starts at, it looks like -1 again, all the way to 0. So -1 to 0. Union, where is it also greater than 0? Right here. That starts at 2 forever. Goes on forever. So 2 to infinity. And then where you're below 0, we're below 0 at 2 spots. Right here we're below 0, and right here we're below 0. So this would be from -infinity to -1. Remember, when you do intervals, you always go left to right. So left is -infinity, all the way to -1. Union, this little portion right here, which is 0 to 2. That's where below 0. And then if you do this on a graph, like we actually put on our calculator like this, exact same question. Where does it equal 0? Well, it equals 0 right there, and that tells us that's at 0.75. So x equals 0.75 is where it equals 0. Where are we above 0? We're only above 0 right here. Is the only spot I see above 0. That's a little hard to see because there's a vertical asymptote, but you cannot tell. There's like an asymptote right here. My guess that looks like it'll be at x equals 2. Well, it does tell you x equals 2 is a vertical asymptote. So you're only above 0 from 0.75 to 2. Like that. And then you're below 0 everywhere else, right? We're below 0 here and here. So that'd be everywhere else. So let's put that down. So it'll be -infinity to 0.75. Union, and then this starts at 2 because of vertical asymptote, 2 to infinity. So there we go. So that's how you solve a rational inequality given a graph. You just look at it and go, okay, where does it equal 0? And then where is it above the x-axis, and where is it below the x-axis? Next, how do we do it without graphing? So the way you solve rational inequality without graphing, it's a little involved. So step 1 has to set equal to 0. So if necessary, set so that 0 is on the one side. So we have to rewrite it so that 0 is on one side. And then what we're going to do is we're going to separate this. We're going to set the top equal to 0, and we're going to set the denominator equal to 0. So the numerator and denominator both get set equal to 0. This is going to find our, what I like to call critical points, but our zeros and our undefined values. And after that, we're going to make a sign chart. So So that's going to be kind of the idea here. We'll make a sign chart and we'll do test points to figure out where we get our answers at. So let's just start it. So set equal to 0, done. Next, we're going to separate it. We're going to set the top equal to 0. And we'll set the bottom equal to 0. This will give us what I'd like to call our critical points. So we just solve each one. So this one we add 2 to both sides. And I get x equals 2. Over here we take the square root. Square root of 0 is 0. So we have 2 critical points, 0 and 2. So next we're going to do a sign chart. So now the reason at x equals 2 is our first one here. I like to do a dotted line because that came from vertical asymptote. Right, when we set the denominator to 0, it's a vertical asymptote. So I do like a little dotted line. And this is my thing here. And then at 0, that was from the top, so at the 0, I just put a straight solid line there. So like that. And what a test point does is this. We want to figure out if the value here is positive or negative. So we're going to pick a point that's less than 0, something easy like -1. We'll pick a point between 0 and 2, something easy like 1. And we'll pick a point on this side, something greater than 2, so like on a 3. And we're just going to type it into our equation here and want to see if it's plus or if it's positive or negative. And we'll walk over there. So this is step 3. We're doing step 3 to test values from each interval to determine blah blah blah. So I pick my test points, right? -1, 1, and 3. I'm going to plug them in there and see if it's positive or negative. So let's plug in 1. So -1 squared over -1 minus 2. I get 1 over -3. So that's a negative. That's all that matters. I don't care about the value. I just care that it's negative. Let's plug in 1. So I get 1 squared over 1 minus 2. So I get 1 over -1. So it's also a negative. And then the last one here is 3. So let's type in 3. X equals 3. So I get 3 squared over 3 minus 2. So I get 9 over 1. And that is a positive. So this one's positive. So what is my answer? Well, what did I want? I wanted where the thing is less than 0. Less than 0 will be negative. So my answer is here and here. That interval will be -infinity to 0. And then 0 to 2. There is our answer. Right, now, again, notice how my answer uses the critical points, not the test points. Those are just means to the end. So the answer here is the critical points. So I go from -infinity to 0, and then from 0 to 2. Let's do another one. All right, so another one's already set out equal to 0 for us. So all we have to do now is step 2 is find the critical points. Right, bring it to the top equal to 0. And we're going to set the bottom equal to 0. Right, and just solve each one separately. Now this one's simple. We can solve it. X plus 1 equals 0. X minus 2 equals 0. X equals -1. X equals 2. And then this one gives us X equals -3. So we have 3 critical points this time. This is a nice long graph. Go in order. So -3. Again, I'm doing it dotted just because it came from the denominator, which is like a vertical asymptote. Not a big deal. -1 is next. That came from the top, so solid line, and then 2. Like that. Now, before I pick test points, it's actually a good idea to write down our possible answers. So my answer could be this section here, which is -infinity to -3. Or it could be this middle section here, -3 to -1. It could be this section, -1 to 2. Or it could be this section, 2 to infinity. Right, so my answer is going to be one of these things, one of these 4, or some combination of these 4 down here. Now we can pick test points. Remember, when you pick a test point, you're just picking something that's in this little range here. Something like between -3 and -1, so -2. Something less than -3, something like -4. Something in this range, 0 is a good option, and then something over here like 3. And all we're going to do with these test points, we're going to plug in and see if we get a plus or minus. So let's plug in -4. So I'm going to get -4 plus 1, -4 minus 2, over -4 plus 3. Now in this case I get -3 times -6, so I get 18 on top, and I get a -1 on the bottom, so it's a negative. Now let's do -2. So -2 plus 1, -2 minus 2, -2 plus 3. So on top I get -1 and a -4. Multiply those together, you get 4 over 1. So this is actually a positive. We could plug in 0. That'll give me 0 plus 1, 0 minus 2, over 0 plus 3. So 1 times -2 over 3. So negative 2 over 3, that is a negative. And then lastly, we're going to plug in 3. So 3 plus 1, 3 minus 2, 3 plus 3. I think it's going to be positive. 4 times 1 over 6. So over 6, which is positive. Again, all I care about is the sign. Now the question here was, where are we less than 0? So again, what are we negative? And we're negative here, which is this answer, and here, which is that answer. So those are my answers. Negative infinity to negative 3, union negative 1 to 2. Okay, let's do one more that's more difficult. So solving rational inequality that's like this, it's not equal to 0. So remember, step 1 is set the one side, let's say the right hand side, to 0. So I go subtract 1 from both sides. So I get x plus 2 over 2x plus 1 minus 1 equals 0. Actually less than equal to 0. Okay, what do I do next? Well, I can't just like separate it right now because there's a minus 1 in the way. I gotta make this one big equation. So I'm not sure if it's part of sub 1 or part of sub 2. You want to combine the left hand side to make one equation. Make one fraction. So with the 1, it's not too bad. We just do common denominator. We multiply this by 2x plus 1. 2x plus 1. That's construction here from the new Performing Arts Center. Anyway, x plus 2 over 2x plus 1 minus 2x plus 1 over 2x plus 1 is less than or equal to 0. Now keep in mind, this is what a lot of people make a mistake. We got to distribute the negative. So distribute, negative 2x minus 1. Oh, this is killing me. So I get negative 2x minus 1 we distribute. Right, so a lot of people make a mistake. They don't distribute negative, and they only subtract the 2x. It's both of them. So distribute. Now we add up. Then we can combine the top. Right, x minus 2x would be negative x. 2 minus 1 would be 1. All over 2x plus 1 is less than or equal to 0. So after you do all that work, now it's just like a problem we did before. Oh, okay, we have it down to something less than or equal to 0. Now we just find the critical point, so the top equal to 0 and so the bottom equal to 0. Negative x plus 1 equals 0. 2x plus 1 equals 0. So we're going to add the x over, probably the easiest way to do that. Over here we're going to subtract 1, and then divide by 2. So x equals negative 1/2. Remember, these are our critical points, so next we're going to do a sign chart. Negative 1/2 comes first. And that, again, doesn't really matter, but since it came from the denominator, I'm going to do a little dotted line. It will matter in future calculus and stuff. X equals 1. So there we go. Again, before I pick my critical points, just so it makes it a little easier for us, I'm going to put the possible answers for us. Negative infinity to negative 1/2. Negative 1/2 to 1. And then 1 to infinity. Right, so those are our possible solutions. Now to figure out which one actually works, we'll pick test points. Remember, we're going to plug it into this equation. Actually, I want to bring it down so I don't forget what I'm plugging into. So that ugliness. Let's see if we can erase all of that. No, it doesn't erase, so whatever. Plug into that thing. Anyway, let's pick our test points. So something less than negative 1/2. So I'm going to go with like negative 3. This right here, between negative 1/2 and 1, actually not that bad, 0. And then something over here, like 2. And all we want to do is sub it into there and see if it's plus or minus. So I'm plugging negative 3, so I get negative, this is x, negative 3. Negative 3 plus 1 over 2 times negative 3 plus 1. So I get 3 plus 1, which is 4, over negative 6 plus 1, which is negative 5. So I get a negative. Again, that's all that matters. Next, plug in 0. So I get negative 0 plus 1 over 2 times 0 plus 1, and I get 1 over 1, so positive. And then we're going to plug in 2. X equals 2. By the way, it's not always less than, sometimes it's greater than. I don't know why I picked 3 that were all less than, my mistake. Anyway, move on. Let's plug in 2. So maybe negative 2 plus 1 over 2 times 2 plus 1. Which is negative 2 plus 1, which is a negative 1 over 5. So this is negative. Again, in this case, I wanted less than, so my answers are going to be here and here. So there we go. And that's the lesson.